helping India reduce its dependence on fossil fuels through wind is CWET. Its research facility is dedicated to developing wind technologies for the new age, including identifying the windiest parts of India in order to generate wind power. How do they do that? That's where the Wind Atlas comes in. Just like an ordinary atlas gives us a map of land masses, continents, countries, and oceans, a wind atlas gives us a complete view of how winds blow in different parts of the globe. It tells us the critical information needed to generate wind power, that is, wind speed and wind direction. But mapping the changeable winds of India is no easy task. From supercomputing to field measurements, it requires every resource imaginable. CWET's first job was to enlist the help of world-renowned wind energy experts from the Danish institute RISO DTU. These experts developed computer programs that mapped wind flow across the entire globe. Indian scientists collaborated with them to understand how these global weather patterns could be applied across India. Together, they developed a mesoscale model for India. But what does mesoscale model mean?
What we call as mesoscale model is based on weather models, large-scale circulations on the atmosphere, on any country. So India being a big country, India was divided into 11 different zones.
Indian and Danish scientists studied global weather models. They then computed the complex weather data using parallel and supercomputing. The data described wind flow at a height of 1 to 2 kilometers above the surface. But that still wasn't enough information needed to set up a wind power station. Most wind turbines in India are not as high as 1 to 2 kilometers. At lower heights, where they are set up, like 100 meters, wind can behave quite differently indeed. This meant that the purely digitally computed wind atlas was still incomplete. CWET scientists would have to venture out into the field to fine-tune the measurements for lower altitudes.
We always believe measurement is reality. So the measured quantity is the benchmark. The digital representation is a indicative wind potential at any location.
In the last decade, teams like these have erected measurement masts at 640 stations across India. The masts reach a height of 120 meters and can be lowered or raised to measure wind at 50, 80 or 100 meters. Each measurement mast is fitted with sophisticated wind instruments.
This is the actual typical model of the meteorological mast. It's a scaled down model. The model which contains the different instruments at a different level, which contains anemometer. The anemometer which measures what is the wind speed existing at the particular location, and this is called wind van, which measures the wind direction, which direction the wind which is blowing. The other instruments also we have it. This is called the temperature sensor, which measures what is the temperature at the particular location, and this will measure the atmospheric pressure. So all this data are being logged into the data logger. So in wind industry, we need every 10 minutes average of the wind speed. So this every 10 minutes average of wind speed is being stored in this storage device.
The full-scale masts are erected whenever there is a possibility of setting up a wind farm to generate electricity.
We are standing at the field, wind turbine test station. So now a wind mast is being installed. The mast which has different instruments, that wind anemometer, wind van, temperature sensor and pressure sensor. The data will be collected and it will be stored in the data logger. It will be analyzed at the office. This data will be used for verification of our wind atlas.